Estimation gives you a simplified answer. Helpful, but we still have to show the range in which the actual answers are at. So how do we use it? This video will give you the answer. Quick recap before we start. Rounding reduces the digits of the number, making it more presentable and easier to calculate. We choose the amount of decimal places and significant figures we round up to, which will in turn end up affecting our answer. For example, the number 3.746 will be 3.7 if rounded to 2 significant figures or 1 decimal places, but will be 3.75 if rounded to 3 significant figures or 2 decimal places. So error bounds, values dependent based on your rounding. It gives us a range of the true value after the number is rounded or truncated. To find the error bound of a value, you identify the largest and smallest number the real value can be, then show it as an inequality like this. For example, you want to find the error bound of 3.5 that is rounded to 1 dp. You will find the largest number that rounds up to 3.5 as 1 decimal point will be 3.55, as anything more than that will be rounded to 3.6 instead. You would then find the smallest number rounding to 3.5 as 1 dp will be 3.45, where anything lower than that will end up being 3.4. Therefore, the error bound for 3.5 1 decimal point will be 3.45 larger or equal to 3.5 larger or equal to 3.55. Seems hard, but luckily there's a general formula for you. For number n that you can get from rounding to the nearest x, its error bound will be this. If you get anything about decimal places, just remember it is still referring to a nearest number, such as 1 dp actually means nearest 0.1 and 2 dp means nearest 0.01. Unfortunately, you can't do this with significant figures as there will be exceptions. The place value of the rounding will change depending on the number. An example of this is if you round 100 to 1/5. For this largest number, you will get 150, as anything more than that will go to 200. For the smallest number, however, you don't get 50 though. Because if you think about it, number like 73 don't get 100 as their closest 1SF number, but get 70 instead. So actually, the smallest number is 95, that will actually be rounded to 100 if it is to 1SF. The error bound will therefore be 95 smaller or equal to 100 smaller or equal to 150, which shows us there will be no formula for this. So you know what error bounds are, but can we use it in calculations? The answer is yes. Before anything starts, just a reminder that upper bound is the maximum actual value and lower bound is the minimum actual value. The idea is simple. Let's say you're given an error bound for 2 numbers. For example, 40 to nearest 10 and 200 to nearest 100. If you want to find the upper bound of the sum of these numbers, you do the upper bound of 40 plus the upper bound of 200, which should get you 45 plus 250, giving 295 as an answer. And again, there are basic equations here for you if you're trying to calculate with upper or lower bounds of a number. There are 4 of them here. You do not have to remember them exactly. The smaller the number for subtraction or division, the larger the result. Therefore, you use the opposite bound of the result when looking for subtraction and division. So in conclusion, error bounds show you the range where a rounded number's real value lies. The general formula for an error bound of a number n rounded to x is this. Error bounds can be used in calculations. For addition and multiplication, you use the same bound as the result has asked you. For subtraction and division, you use the opposite bounds as the result has asked you to find. And that's it for this video. Do not forget to subscribe and I'll see you on the next video.